problem number 6. 2949. I have here infinitely long wire, which is of course always very unpractical, and it is drawing a current I1. And here I have a loop, a rectangular loop, and this distance equals R1, and this distance equals R2. This loop itself has a current going through it, I2. And the length of this arm equals L. And the length of this part, of course, is R2 minus R1. There is a magnetic field, and that magnetic field is perpendicular to the paper. It's in the paper, and it's uniform. And as a result of that, each one of these four, this magnetic field, by the way, I was a bit misleading, is the magnetic field that results from this current. And so I put a 1 there. This is B1. So I only am considering the magnetic field as a result of the current in this wire. So it will be strong here, and it will fall off as 1 over R when I go further out. And now I want to know what the forces are on these four sides. Well, the force here, and you should convince yourself of that with the simple fact that you know that the force equals I times L cross B. You can convince yourself that the force here will be down, the force here will be up, and these two forces will exactly cancel each other. There will be a force here outwards, I call it F2, and there will be a force here inwards, I call it F1. And these two are not the same because they're at different distance, R2 and R1. So this force is clearly smaller than this force. This force is winning, because F1 must be larger than F2 in terms of magnitude. So, I now want to calculate what the magnetic field is as a function of distance from this wire. I use Ampere's law, and I will get back to Ampere's law later. So even if you can't follow this answer right away, then you will see later how it evolves using Ampere's law. But I assume that by now you may know that the magnetic field outside a straight wire falls off as 1 over R. So the force F1 minus F2, which is the force in this direction, will therefore be mu 0 times I1 divided by 2 pi, and I have 1 over R1 minus 1 over R2. And that is the force, and there isn't really much more that I can add to this. Wasn't all that difficult, so the loop wants to move in this direction.